Now this illustration deals with an effective ground fault path. Now, to me, 250.68b as in boy ties directly to 250.4a5 for an effective ground fault path. Now, it used to say a system just had to be effectively grounded. Well, engineers, contractors, and electricians had a problem with this sometimes with plan checkers, sometimes with the authority having jurisdiction. What is considered effectively grounded? What do we have to do to make sure a system is effectively grounded? And it run into a lot of detailed procedures. So there was a proposal come in that said, okay, an effective ground fault path can be proven in this manner. Say up there where it shows to the weatherhead, 230.54, say those conductors again were 4-aught coming through that meter base and connected to a 225 amp main in the service equipment. Then we would go as designers or installers to 250.142, A as in apple, and we would say, okay, this is supply side because there's no overcurrent device ahead of those conductors from the secondary side of that transformer. So based upon 4-aught again, as we've illustrated a number of times, we need at least a number 2 grounded conductor, pulled with those phase conductors, routed with them, to the service equipment and connected to that bar, bonded to the service equipment and connected to the metal water pipe. And we would use number 2. But if we should install say a 20 amp circuit and run it and select, supply some lighting outlets, receptacle outlets, and so forth, then we know the equipment ground by 250.142b as in boy, so size that equipment ground off of the overcurrent device. So 20 amp overcurrent device, we'd go to table 250.122 now, and that'd be number 12. Now we have an effective ground fault path if we use all the fittings necessary to create a complete bondage system. If we use bonds and bonding conductors, as you see, bonding that meter base in the illustration. And then the note says a bonding jumper shall be used to bond around the meter to provide an effective grounding path when the meter is removed. So this deals with an effective grounding path, and we're using bonding jumpers, maybe connectors and other things to provide this effective grounding path. But the effective ground fault path is 250.4a5 that we have to provide, and it's either supply side bonding and grounding, 250.102c1, or load side grounding and bonding, table 250.122. So this illustration, 16-87, is dealing with an effective grounding path and what we have to do in the system to make sure that we always have an effective grounding path and nothing interrupts your grounding and bonding procedure.